Good afternoon, everyone. Welcome to our webinar. Today, we'll be focusing on integrated project workflow with Common Data Environment. This is the first webinar in our webinar series, and we'll have upcoming webinars focusing on precast constructible design, rebar constructible design, Trimble Connect status tracking dashboard. You can visit our website You can visit our webpage for more details on the upcoming webinars, as well as access past webinar recordings. My name is Patricia T, and I'm your host for today. It is my pleasure to introduce the speaker we have for our webinar today. Alfred is the Director for Services and Consulting. He has 30 years of experience, and his expertise covers from design to construction. He has extensive experience in structural consulting and fabrication work. He is responsible for providing technical support and training to the building and construction segment in the Southeast Asia region. He has successfully value-add and gamified customers and business processes that lead to increased productivity as well as cost savings. He'll be showing you more on integrated project workflow with Common Data Environment. We also have the following panelists with us today. Tusha, whom is the Digital Innovation Lead at Soil Build Construction Group. He focuses on adoption of integrated digital delivery into the company's work processes and projects. We also have Mark Sui Chang, who is one of the digital lead and associate principal at Arab Singapore. He is the professional engineer for Singapore Flyer, Singapore Sports Hub, Paya Lebar Quarters, and National Cancel Center. We also have Kuwait, who is the BIM manager at War Hub Private Limited. Please note that we'll have a questions and answer session after the presentation. You can ask your question at any point of time using the control panel, and we'll address them at the end. Before we begin, I'd like to ask all of you to close all other webinar applications, then go to webinar. Please also view the webinar in full screen mode to get the best optimal webinar experience. Should there be any problems with the audio or picture quality during the webinar, please use your control panel to interact with us, and we'll try our best to help you. With the questions tool on the right-hand side of the screen, you can type in questions at any point of time during the webinar. We'll try to answer as many questions as we can at the end of the webinar. We will also be answering some of the questions online using the questions tool. If we are unable to answer all of your questions during this live session, we'll get back to you via email. This webinar will be recorded and we'll send you the link to the recording this week via email. The recording will also be posted on our website at tekla.com/sg/webinars. Over to you, Alfred.
Okay, let me share my screen. Maybe Pat, you can help. Pat, maybe you can help to share my screen.
Yeah, give me a minute. Yeah.
Sure, thanks. Yep, maybe not this screen. Can I change to the other one? Okay, maybe you do it. Okay, now I see it.
On the end, yeah.
Okay, that should come. Yes. Okay, thank you, Pat, for the introductions. Good afternoon, everyone. I'm Alfred Hung from Trimble Solutions Singapore. In today's webinars, I would like to talk about a research project that Trimble undertook last year, that is integrated project workflow with Common Data Environment. Some background information on the project. The project was funded by Ministry of National Development, MNDRF, Singapore. It was a one-year project started April 2019 and completed in March this year. Trimble took up this project as the principal investigator, and I am the project lead. Together with me, Tay was providing engineering input and tester involved in software development. For this project to produce practical results, it is important to have industrial practitioners taking part in the projects. We have 4 project collaborators in this project. Mr. Mark from Arup Singapore, Kuwait from Wahab, Tusha from Precast Concrete or Soybuild, and Mr. Chang from BRC Asia Limited. Mark, Kuwait, and Tusha are with us today as panelists. So if you have any questions during the presentations, feel free to raise your questions, and they will share their experience and comments to you during the Q&A sessions. And of course, outside the official engagement, we are talking to other key players as well in the industry, such as Robin Village and Sunway Precast, to gather feedback and comments. These slides show the overall views of this one-year projects. Obviously, there are endless possibility on what we can do on workflow integrations. But for this one-year research project, we limit ourselves to a few selected focus areas for each project stages, from design, fabrications, access, delivery, to constructions. At the centerpiece of this project is the Common Data Environment, a centerpiece to hold project informations and to make integrations of various processes possible. On the aspect of structural design, we explore the possibility of bridging the gap between precast element design and fabrications. With constructible design, we hope to achieve a situations where fabrication details are ready when the structural design is complete. Meaning, when the design of precast elements is done, fabrication details and shop drawings are available at the same time in one integrated process. And next, we look into streamlining rebar fabrication ordering process. Rebar data is extracted automatically from BIM models, uploaded to Common Data Environment, where ordering details can be generated for fabrication services. The current process involves a lot of manual work. It is tedious and prone to error. With the integrated rebar ordering process, we hope to improve the productivities and minimize the rebar wastage. On the on the materials delivery, we look into the aspect of proof of delivery, where delivery status of each precast element is tracked and deleted documents are generated. Last but not least, a status dashboard was developed to track various construction status of precast elements with barcode scanning. The aim was to produce overviews of project performance by looking into construction status in real time. So a few slides on the Common Data Environment. Why Common Data Environment or CDE matters. Typically, a project involves multidisciplinary stakeholders, and a successful completion of a project relies heavily on joint efforts of various project parties. Each party may have different workflow depending on its respective roles in the project, and various types of construction technologies and software tools are in use. Each of them may or may not compatible with each other's in terms of information sharing. It is common in our industry that the project information keep changing, revised, and updated during the project implementations. So all these challenges leads to information silo, poor communications, and data misinterpretations. So to resolve these issues, the current trends in the industry is to adopt common data environments so that there's only one single centralized source of information for the whole project team to collect, manage, and disseminate project informations. So informations contained in the environment could be 2D documents or 3D graphical BIM models. For this particular research project, Trimble Connect was used as the CDE platform. In phase 1 of this project, which lasts for 5 months, a thorough study was conducted on Trimble Connect to investigate and validate key functionalities of Trimble Connect as a CDE platform. I will share a few more on the finding on Trimble Connect in the next few slides. Okay, so ideally it is best if there's only one single super solution in use in the industry, that we don't have the issue of information exchange between team members. But in realities, because of multidisciplinary teams and diversities of file formats in use, it is not the case. And I believe the situation is not going to change soon, and certainly not in the near future too. So a CDE platform has to be open and inclusive. So CDE platforms such as Trimble Connect adopt open standard approach. It supports most of the industrial standards. Collaboration between project stakeholders is hence possible, irrespective of the file formats in use by the project stakeholders. So it is worthwhile to mention the Open BIM standard. It is a common standard maintained by Building Smart. Most major BIM authoring tools, such as Tekla structures, are compatible with the open standards. They are IFC certified. One of the key benefits of this open BIM approach is that it is vendor neutral. Users are not tied down with any specific software tools or any specific software version. It allows federations of models. It doesn't matter now if architects, engineers, contractors are using different BIM authoring tools. And the object attributes, identities, and relationships are codified in IFC schema. Properties and attributes of the objects are retained and not lost in IFC exchange. And hence it makes the workflow integration possible. This picture shows federations of models from different disciplines from various sources to form a single federated model. A single federated model is useful for design coordinations, crash detections, estimations, and approval processes. The individual models have clear ownership and remain separate. This means that the liabilities of each individual models remains with the owners. Hence, separations of ownerships and liabilities. This is Trimble Connect's desktop versions. MEPs was uploaded onto Trimble Connect desktop as IFC files and presented in a 3D environment. So similarly, models from other disciplines can be exported as IFC files from their respective authoring tools and upload to Trimble Connect. So as mentioned before, it is possible for us to interact with the objects, such as changing the object transparency. With the structures model turned on as well, we can now see the interactions between architecturals, MEPs, and structures models. And of course, each object is attached or associated with its respective properties, attributes, such as weight, length, concrete grade, etc. And the same should apply to rebar as well. So rebar properties such as rebar length, weight, shape code, etc. can be inquired from the models in CDE platform. So the single federated models is consisted of individual models from architect, structures, and MEP. Next. And one of the key criteria for CDE is that information is derived from one single source, in my opinions. Information should be centralized and disseminated from one single source. This means that we are looking at cloud-based solutions. In case of Trimble Connect, it is cloud-based with project servers located in 3 continents. Trimble Connect infrastructures runs on AWS, Amazon Web Services. So data is easily accessible, while several choice of client applications. In this case, Trimble Connect runs on web, desktop, mobile, and HoloLens. Because information is accessed from one single source, then information is always transparent, consistent, up-to-date, and traceable. Trimble Connect runs on HoloLens, a mixed reality technologies from Microsoft. With the technology, it is possible for us to overlay virtual BIM models onto physical environment, such as construction site. It is immersive and intuitive. I guess MR technology is not something new to some country, but probably that it is something very upcoming to many areas. So one of the same sample application is to use it for site inspections. This video shows the application of MR technologies on site, where 3D models merge with site physical environment to visualize the site progress. checking on which elements has been installed and which have not. Alignment inspections is another potential use, as well as on the assisting of assembly work. So in this case, with the help of MR holographics overlay, the engineers conduct site inspections well before the actual installations. So federation of several highly detailed models means that the total file size is getting bigger and bigger. And we need data-rich models in order for us to make well-informed decisions. But with so much information to be handled in the CDE platform, the next question naturally is to ask, can the CDE platform cope? So platform robustness is very critical if CDE platform were to fit for the purpose on the workflow integrations. If objects are modeled at boundary levels, then we shouldn't have any issues on handling them. But when we talk about highly developed constructible models, then it becomes a bit more complicated. The platform has to manage more than graphical representations of each element. Functional, operational, and directional information should be handled as well. So it becomes more challenging for the platform when models are federated for the whole project. So the expectation is that the platform should remain responsive to be of practical use. This video shows projects with a total of 2 gig file size, complete with architectures, MEPs, structurals, including reinforcement bars. So with this amount of information contained in the platform, it is good to see that the platform is still performing rather well. And you may notice that it is actually running on the web, not on the desktop. So platform performance has been improved over the last 2 years as far as the Thermal Connect is concerned. Okay, next. In a project, typically we have mix of 2D documents and 3D models. And 2D documents are like a sample of 2D documents are tender documents, spec, drawings, progress reports, site photos, etc. Some documents are project specific and some are related to certain elements of the BIM models. One good example is the shop fabrication details. The details of particular elements are represented both in 3D models as well as in 2D shop drawings. Both are representing the same object but are presented in different format. So this video shows a fully detailed column with 2D shop drawing associated to it. The associativities have added benefit in terms of accessing the deleted information for further processing. In this example, subdrawing, checking, and approval. Comments are added onto the subdrawings with markup. In this case, that highlighting unknown shapecode. Creation of a new task to highlight the problem with full descriptions to describe the problem at hand. In this case, is please rectify the unknown shapecodes in the models, giving some priority and due dates of the job need to be done, and it can be classified as an issue and assign the task to someone to follow up. An email notification is automatically sent to the assignee. And of course, the task is always recorded and tracked in the background. Another key functionality of Trimble Connect as the platform is that it maintains full audit trail. All activities are captured from beginnings until the end of the project. For example, from this activity log, we can see that Jeremy has added a new MEP view on 13 May. And on the same day, he deleted a picture files in the afternoon. This deleted file can always be restored anytime if needed, because information never get deleted from the platform. Another example, Kelvin have downloaded IFC files on September last year. And in this case, Ian has synchronized the project with his local desktop on August last year. So for a project with so many team members, it is very crucial for each activity to be tracked and traced. So another important aspect of project collaboration is on keeping track of revisions and changes. Example in this video shows that there are revision done to the MEP basement. The file has been uploaded twice. Revision numbers is automatically assigned by Trimble Connect. So at any one time, user can revert back to the older versions for review. So enough talk on the common data environment. Now let us move on to the project focus area. On the project design stage, we are looking into possibly bridging the gap between structural design and fabrication details, where the structural design is completed with the inclusion of fabrication details. So it is common that structural engineers perform precast element design in spreadsheet. For example, wall calculation sheet. In this case, let me open up the example. So you can see that this is one example of the spreadsheet calculations on the precast wall. So calculation is done in Excel. Similarly, reinforcement details of beams or walls are normally tabulated in Excel spreadsheets as well. So with the precast element design tools, this design information is transferred into Tekla structures where beam or columns are detailed based on the design information. So once the elements are detailed accordingly, the respective shop drawings are generated from the BIM models for fabrications. The shop drawings can be uploaded to Common Data Environment platform for approval submissions. So the process is illustrated in these videos. Because Plank is first modeled in Tekla structures, the BIM authoring tools. So in this project, a precast element design link was developed. The design link will gather geometrical informations from the model and pass the informations over to Excel spreadsheets for design calculation in the background. So as you can see, the design link read in geometrical information of the plank. The plank thickness is 125 mm. The length is about 2.5 meters. The user provide additional design parameters for the calculation. All this information is transferred in the background to the Excel calculations for the plank. So once the design is completed, the design outputs are transferred back to BIM models. So now the plank is now fully detailed with the correct reinforcement size and spacing, and now and ready for shop drawings generations. So in this case, we are creating carcinate drawings for this plank. And this is the shop drawings for that particular precast plank. So with this integrated workflow from design to details to shop drawings, and I would say that this is something to explore on improving the workflow. Let's go to the next one. Similar process applies to the precast connections as well, connection between the two walls in this case. Against the design links, read in the connection details of the wall. And we can see that the wall is about 2 meter length, transfer read from the BIM models to the calculations. Thickness is about 200 mm, concrete cover 25, existing link size 10 mm, etc. So user define additional design parameters. So, and the connection details are updated according to the design outputs. So the pipe sleeve, initially there was 5 numbers of them. And now because the calculation saying that we need only 4, so the details are updated to just have 4 pipe sleeve in this case. For the standardized reinforcement tables, rebar information is read in from the tables, from the schedules in Excel and transferred over into BIM models. In this example, the BIM is detailed according to rebar information gathered from the reinforcement schedule table. Rebar information is attached to the BIM. As you can see here, so we might see that top bars 2 hex 13 plus 2 hex 13, there are 2 layers of the top reinforcement bar. And if we modified the rebar informations from 2 layers to 1 layers, then the beam details will be updated as well into just 1 layer in this case. So getting design information from spreadsheets into the beam detailing environment. Okay, let's move on to the SOP detail submissions and approval process. So once the structural design is complete and the BIM models is fully detailed, SOP drawings can be generated directly from the BIM models. Under this project, a tool was developed to address the SOP detail submissions and approval process. SOP drawings are uploaded to Trimble Connect and automatically linked to the corresponding 3D elements in the models. To keep the tool keep tracks of the submission status, color code each drawings and elements according to their respective submission status. As you can see from the submission list, you can see that the lists are color coded with different colors, as well as the elements in the 3D model views. So each color represents certain submission status. And during the approval process, the checker or the structures engineers has the options of reviewing the details either in 3D environments or 2D shop drawings. So hopefully this improves the visibilities and gets the shop drawing approved faster. This video shows the submissions tool, and you may notice that in the 3D model view, the elements are represented in different colors because of different submission status. When they are ready for submissions, 2D drawings are uploaded to Trimble Connect. I'm not sure if that play. Okay, yep, now it is. Yeah, so 2D drawings are uploaded to the platform by the detailers, and the drawings appears in the drawing list. In this case, orange colors. And at the same time, if you notice, the corresponding elements that the SOP drawing represents are changed to the orange color as well. So by looking at the colors, then we know which drawing has been submitted, which drawing has been approved, and which elements have not have any SOP drawing submission yet. So this provides good visibility of overall approval status. So on the approving end, the engineers then have the full visibility on which drawing are pending for his approval. So if the details are acceptable to him, he can then approve that particular drawings, and the status get updated immediately to both approving engineers and submitting parties. So as you can see, the approved drawings are now marked in green colors, as well as the corresponding elements of that SOP drawings. So next, rebar fabrications. The plan is to streamline the cut and bend ordering process by developing a BIM-based applications to extract rebar data from BIM models onto CDE platform for further ordering processing. There are two components in the cut and bend ordering process. Order requisitions put up by BIM detailer, order placings put up by project managers or whoever is responsible for the rebar fabrication ordering. The first components reside in Tekla structures, the ordering environment, dealing with rebar data extractions and grouping, uploading of the rebar IFC to CDE platform, and keeping track of order status. The second components interacts with CDE platform, Trimble Connect. Its key functionalities are purchase order generations and order status tracking. So to put it into actions, this is how the order requisitions components work. So in Tekla structures, the detailers select those elements which are ready for cut and bend ordering. And the tools will extract the rebar informations from the selected BIM elements and group the rebar into several categories. So for example, in this case, we would like to exclude straight rebars from the orders. The detailers can perform a final check on the selected items by highlighting the rebars in the models. So once he is happy with the selections, he or she can then proceed with the order requisitions and upload the rebar data onto Trimble Connect. Okay. The detailers at his end has full visibility on which rebar has been ordered and which rebar has yet to be uploaded for order processing. So this gives some good trackings on rebars ordering status on the models. So coming to the final order confirmations by the project managers on Trimble Connect. To his end, the project managers have the full list of rebar bundles submitted previously by the detailers. Full rebar details are available to him, assisting him in making the order decisions. So additional information on project can be keyed in by him, as well as the PO numbers and the required date for the rebar to be delivered to site. Okay, the required date. And of course, he can make a final check on the orders, looking at which areas of the projects that he is ordering the rebar fabrication for. So against visibilities to help make right judgment. So once confirmed, the rebar orders is generated and updated to CDE platform. So several rebar information are generated, including the bar bending schedules, a summaries of a rebar sizes and the total tonnage, etc. So the orders is uploaded and stored on the platform, and As you can see, there is a files uploaded in the documents folder. Yes. And of course, this file can be forwarded to or downloaded by rebar fabricators for the fabrication services. And on the project piloting on cut and bend, I would like to invite Kuwait from WorldHub to share his comments. Kuwait,
Yeah.
pass over to you.
Hey, thanks, Mr. Alfred. Yeah.
Yes.
Thanks.
Yeah,
I have few slides. Yeah. You can hear me?
Can hear you.
All right,
loud
good.
and clear.
Yeah. I have few slides to share with you on our part as a project collaborator on how we make use of BIM and Common Data Environment for rebar works. So as the first slide, what you see here is a traditional rebar shop drawing. So you know this is manually created by CAD software, and following our rebar scheduler, our subcontractor make use of that information, extract it, tabulate it out, and all this process is manual. And I think, as mentioned by Mr. Alfred before, this process is very tedious, time consuming, and it takes a long process of QA/QC review tracking, and still somewhere got the error. Next, please. Yeah. So to have more clear on what is a traditional workflow and a proposed workflow, I put it side by side. On the left is a traditional workflow. By the way, we are talking about the cast on-site structure. It's not the precast structure. So at first, the rebar shop drawing need to create it, and usually it comes without the bar bending schedule and without the bar marking. This drawing will pass down to subcontractor, and it's a manual process of extract information about rebar shape, lumber bar, rebar diameter. Then all these will tabulate in the table and follow up by rebar supplier on fabrication. So on the right is a proposed workflow. So at first, the rebar model need to work out first, and the rebar shop drawing will be generated directly from the rebar model. And we will put this model and drawing into CDE, and our goal is get the model trust enough rebar information in accuracy, so that our subcontractor, our rebar scheduler, they can make use of information and generate BBS directly from model. Yeah, so that is our goal. Next, please. All right, so we tried this workflow in one of our civil projects. In this pilot project, we split the implementation in few stages. So as the first stage, our aim is just to test out whether the concept of the rebar modeling of the shop drawing come out from model, it can work or not. Because our concern is the project is large. The project footprint itself is already more than 100,000 square meters. So our concern is whether the hardware, software, the presentation of the shop drawing or model can work or not. So this is our aim as the first step of implementation. And after the first step done, we move to next step. The second step is we extend this information to our external party, or our engineer, our rebar scheduler, our subcontractor, or our rebar fabricator. So they will make use of model, go in there to check, review, querying, extract the information. As second step, the rebar information, first time we export as a base information only. So it's still manual go and check and manual BBS, but they give it the information as a first cut to generate up. Okay, and now we are currently at third step where we think the information, the rebar is already accurate and trusted and checked. So, I mean, we have more confidence and we think we're mature enough to directly generate BBS from model. So this is where we are now. In next few slides, I will show you the picture of the model we created. What you see in the background here is a part of the model. The green is a bottom rebar. Those in the black color is a temporary king post, and the solitary system in the gray color. So inside the model, we merge it all together, and the rebar need to consider all this. Beside the rebar detailing, we also need to avoid clashing with all these things. All right, next please. Yeah. So this picture show you the picture combine all the rebar together with concrete profile. A second step of implementation, the instant feedback from user is that I think this CD or 3D effect is a very powerful visualization tool. So what happened is usually for one casting, it takes more than 20 drawings to show all the concrete profile or the rebar detailing. And even with this more than 20 drawings, sometimes it's still not enough information, because in the 2D we cannot cut the section all over place. So with this 3D model, it helps the user have very quick understanding of the design and save them the times on this part. Okay, next please. Yeah, a simple beam reinforcement. And next. Yeah, another is the simple the column reinforcement model. So you might ask, any issue? Yeah, I think as a first phase implementation, we face a number of issues. So I think the first part is how we need to handle this very large model. And second is, in terms of the speed. So what we observe is at beginning, the time to create the 3D model plus generate 2D drawing from model, it takes longer than 2D traditional process. But after a while, about 6 to 9 months after the learning curve, I think the speed almost the same between two workflow. And somehow, if we know about programming, we know about automation and customization, some tasks is even faster by using the model. So in the next two slides, I will elaborate more on the Tekla Open API and automation. Next, please. Yeah. So as mentioned, to speed up modeling and to overcome those very tedious tasks, we make use of Tekla Open API and using programming to guide the customization and application on Tekla. So for example, like create the column rebar, the starter bar from wall, from beam, so on and so forth. All right. So let's take a look with one example. Yeah, next please. So here's one example of the column rebar. So in this project, the pilot project, we have huge number of structure column. And because of the sloping as a rule, because of design configuration, different sizes, different rebar size, and there's many combination of the starter bar for beam, for wall, for slab. So it end up that many type of column rebar. So what we do here, we try to make use of Tekla Open API to do the one program so that it can help to generate the rebar for column automatically. Can you have to play the video, Alfred? Yes. Yeah. So in this plugin, it will take consideration of all the design parameter, number of rebar, the size and shape, whether have beam, secondary beam coming or not. And it also take care of the construction method, whether it's a top down or bottom up. Got different construction method, have different way of the rebar detailing. So that with this, it can create the rebar for most of the column automatically and save us some time on modeling work. Yeah, right here we change the number of rebar. All right. So, but I think this customization require programming skill. Need to do the hard code, which is not easy and not many people can do. So I hope Jumbo Tekla can help conduct more training webinar on this part to help us. All right, Mr. Alfred. I think with that, I
Yes,
hand over
of
back to
course.
Mr. Alfred. Right,
Yeah,
thanks.
Thanks, Kuwait.
Right.
Yeah, for the sharing. Yes. Okay. Yeah. Back to me.
Yeah.
And yeah, one more piece on the next construction stage. We have developed a beam-based status dashboard. This status data is captured by model scanning. By mobile scannings of RFID, QR codes, or barcode, and the 3D model views is color-coded in real time to reflect the latest construction status. So moving on, this is the pilot project that was used to test the status dashboard. It is a HDB residential building, and the selected precast element to track is LPS. The project was fully detailed in Tekla structures. IFC models was exported to Thermal Connect, completed with individual unique ID for each LPS. And the unique IDs of each LPS is mapped with the barcode tagging as shown in the pictures. So each element is attached with its corresponding barcode. And with this, the barcode is scanned. In this case, the element is scanned and assigned to have a particular status. In this case, is in storage status. And once the scanning is done, the information is sent out to a cloud database immediately. And we have actually improved the scanning from scanning each one at a time to a group scanning based on feedback from this project as well. So next, next slide, hold on. Yes, so as a result, the status dashboard is updated immediately. As you can see, this is this was the second element that we scanned during the project. You can see that the panels have changed colors, and as well as there's a small report to reflect the percentage of the progress and a bit of the graphical chart to show. And of course, there's a full history of all the scanning activities. If needed, then of course this can be exported for further processing. Yeah. And this was the dashboard, status dashboard. We actually proceed to look into the access delivery aspect as well. And a simple web application was developed to take records of site delivery with barcode scanning, later on with digital signage, and also automated generations of DO in this case. This apps, as per now, is at its simplest form with potential of further develop into to cover more depth in a later development if there's a real demands from the industry. Okay. Yeah, so yeah, there are so much information available, and as far as construction status is concerned, there has been we have seen a lot of keen interest from the industry. In fact, we have had some contractors in Singapore comes on board using the solutions, the status dashboard solutions in real projects. We have also seen similar interest in other countries like Malaysia, Hong Kong, and South Korea as well. For more information, feel free to visit our IDD website to gain more information. So with this, I end my presentations. Thank you. So over to you, Patricia.
Thank you, Alfred. Thank you, Alfred, for your presentation. Now it is time for us to take some questions from our audience today. Please submit your question by using the question dialog box. You can also send us questions later on via email at tekla.marketing.sea@trimble.com. With that, I'd like to invite Alfred, Tusha, Mark, and Kuet for the Q&A session. So the first question that we have is there any limitation on the file size or number of elements in IFC file when uploading to Trimble Connect? Could you also elaborate on how data is exchanged from different software used by different collaborators?
Yeah, I will take up this questions then. On the limitations of the file size or numbers of elements in IFC, and a few areas to look into. Of course, the first thing is that which type of Trimble Connect license that you have, and of course, for the free versions of the Trimble Connect, there is a limit. There's a limit on the file size. But as far as the technicalities of Trimble Connect to handle big models on the projects, chances that the platform is robust enough to handle the big projects. My side, I have been testing it with several projects of certain size, at least with 2 gig file size. And I guess similarly, I think QED has also been testing the platform with his very much complicated projects. So we don't see problems so far in handles realistic project size in Trimble Connect. And then on the second part of the question is on the how data is exchanged from different software. For at least for Trimble's, we believe in open approach that in the industry there are so many specialized software, each with its strength on certain area, serving specific functionalities. So we believe in the open standards of working with all the possible popular software or tools out there. So one of the ways for us to address this is to going to the open standard like what Building Smart is promoting using IFC. So with this IFC, then we are able to take in models from different sources. Doesn't matter which software type they are using, and we are also free from different versions of that particular models. So very much what IFC is for nowadays. Yeah, hope that I answered that questions. Thanks. So Pat, back to you.
Alfred, the second question that we have is, as a practicing structural engineer, what is your view on constructible design, where downstream requirements needs to be considered during early structural design? Another question that we have from the audience is from Dr. Tan from BCA on the benefits experience.
Yours. So maybe Mark, you are the right persons to take up these questions.
I think the benefit, like what Alfred mentioned, is pretty endless. It really takes a bit of an idea, but you must get a team to write a bit of a script in order to tag onto the CDE environment. So the work that we have been doing with Alfred is more or less like that. So we tell him a problem, and then he start to write scripts, to address some of the issues that we are facing. So one example was shop drawings. So we were kind of complaining that, to Alfred, shop drawing seems to be endless and it's always coming every week. We can't seem to be able to see the end of the tunnel. So what he did was basically what he presented, that is to allow us to have more visualization of with respect to the building itself using the beam information, and allow us to appreciate exactly where and what we are approving and what more to come. So I mean, as a project manager for the structural team, this will be quite advantageous because you can plan your resources ahead, and therefore have somebody there to deal with the issues that the contractor might face. So indirectly, the quality is achieved. And I mean the information, how things are presented, that can help you visualize things, and the response will therefore be more accurate and less back and forth of information between the two parties. And Alfred also link up our design spreadsheet with obviously through again the CDE environment, making use of the information that was fed into this environment to write a script at the back end produce a calculation whenever the contractor might want to change certain things like the rebar requirement or perhaps even the thickness of a panel. So shop drawings can then perhaps in the future come with a calculation for the engineers to look through and check. So again, this saves quite a bit of time. I mean, I think yeah, there's so many things to discuss about, which will go beyond my time limit, to be honest with you. But I hope I can inspire you guys to latch on to this kind of thinking and workflow. Yeah. Alfred,
Thank you,
did I say enough?
Yes, of course, I agree with you. There's so much that we can do to look into the integrations. Yeah. Yes,
Thank
Pat,
you, Ma.
back to you.
The next question that we have is, each rebar fabricator has their own requirements on rebar modeling, such as shape code and bending parameters. How do you handle this issue during beam modeling? Also, rebar modeling tends to increase the model size. What is your experience on platform stability?
So, QED, this is your turf.
Right. Yeah, I think this is a very good question, and this is a problem we're also facing at beginning of implementation. So at first, yeah, different rebar fabricators, they might have different kind of standard and like different bending drivers, different rebar laminar, and the coupler length, all this might be different. So what happened is, I think if you're lucky, some of rebar fabricator, they already create the template by themselves. For example, like we work with Last Steel, so they already create the Tekla template with built-in all their standard shape code and other parameter, so we can incorporate that template in our model, and we are not worried of whether the information extract is whether tally with their cutoff or their standard or not. But it might come to second case is some rebar fabricator or supplier, they might not don't have the rebar, the Tekla template. So in this case, no choice, we need to do the customization and set up in Tekla model. But the complication comes is in one project, you will supply, you split the rebar to send it to two rebar supplier. Then this is complication. I think this in this case, mainly for us, for this item is related to second question, which we need to split the model accordingly. So maybe I come to second question. Yes, I think our wish is to have one single model to control all everything. But in the actual, I mean, to get the models stabilized, we do need to segregate model. For example, like in our case here, we split precast with cast in situ, and within the cast in situ structure, we also split by slab, or even within the slab itself, because the footprint of project too large, it's about more than 10 football field. So we've split the model furthermore by construction zoning. So with smaller model, I think model is more stable and easier to control. So this is how we manage the model. I hope that will answer your question.
Thank you, QED.
Yeah.
The next question that we have is, what is the impact of status dashboard on project collaboration among stakeholders?
Tusha, you want to take up these questions?
Sure. Thanks, Alfred and Patricia, for the question. Well, basically, the ability to uniquely identify the components and track them within the factory and also beyond the factory as well increases the overall efficiency for production planning, storage, delivery, and also for the installation at the project site, right? At the same time, it also kind of allows for greater coordination between the design team, production team, logistics, and the site team, which is a very crucial aspect in terms of those plants which are operating under the just-in-time production principle, where time is really of the essence, right? The other aspect is that the interactive dashboards kind of enables the different project stakeholders to track each individual unique component or element throughout its life cycle, which allows them to better manage the overall project's progress. Other than that, I think the status the dashboards also eradicates the need for having a conventional Excel wall chart system, which which is traditionally used. So basically, there is a easier tracking via illustrations through the color-coded BIM models, which Alfred presented earlier, and also through the various graphical representations. So basically, I mean, the project site team don't need to call the precaster team to check about the status of the precast elements on a regular basis, right? Overall benefits, I think, could be termed in the sense that it allows for digital logistics management, digital ordering and manufacturing, which I think Alfred also showed earlier that through this project we also use a digital delivery order where previously it was available in paper-based formats. So digital ordering can also be done. Digital delivery. It also allows for site progress monitoring, and all of this is possible through the cloud-based collaboration where we can upload the BIM models on the cloud and navigate it through to see which elements are there, which elements are still to be produced, and which elements the shop drawings are still to be created and generated and sent across for approval or and things like that. Yeah.
Thank you,
did I answer
Tusha.
that question? Yeah. Okay.
Thank you, Tusha. The next question that we have is from Ishan from Excel Precast. Is there any function to link up to any ERP software for claiming purpose?
Yes, maybe this I will try to answer. I guess from using the BIM data for claim purposes, there are maybe already some developments happenings in the industry, but we have internally also among ourselves and with the project collaborators here, we have some discussion as well. Basically, there's a possibility in our view is that we can extend the status tracking a bit more to look into the claim purposes. Like, for example, at the very basic level is that some claims are based on certain status. Like, for example, for precaster like Excel, probably you make claims based on certain production status. Like, for example, if a precast element is cast, then you claim probably certain percentage, and then once it's delivered, then you claim another percentage. And this data of the status actually is available if we are using the RFID or barcode scanning. And so if the dashboard is there, meaning that we can then extend the functionality to include the status to look into the claim. But of course, the claim involves a lot more because then you have project schedule, you have any other things, the documentation side to make claims and the calculations, all those you'll get involved as well. But I think it is a natural extensions of the status dashboard that we have. So the possibility are there actually. Yeah, just to share my thought on this. Yeah.
Thank you, Alfred.
Yeah. So Is there any other questions or? Yep.
If you have any other questions, you can always email to us after this. Before I end the webinar, I'd like to share the upcoming webinars that are a continuation from today's webinar. So the next one we'll be having would be precast constructible design. Rebar constructible design, Trimble Connect status tracking dashboard. Apart from those that I've mentioned previously, we have all these upcoming webinars. To all our listeners, thank you for being here with us. Thank you, Alfred, Tusha, Kuret, and Mark for joining us today. There'll be a short survey after this. Do share your thoughts on this webinar with us. Have a great day.
Thanks everyone for attending.
Thank you and goodbye.